Hello, and welcome to the introduction of TP-Link's Outdoor Business Wi-Fi Solutions. We will begin with a brief introduction and an overview of the product line. Then we will discuss common use scenarios and relevant applications. We will then conclude with two case studies that describe successful implementation in Peru and Indonesia. The name Pharos refers to the ancient tower at Alexandria, which guided ships with a light that was visible from many miles away. We like to think that our products reflect this monumental achievement in long-distance communication. The solution is comprised of three key parts. The first is the hardware, the professional outdoor CPEs, base stations, and MIMO antennas. The second is the specially designed interface, which features various tools and a centralized management system. The third is our proprietary TDMA protocol that ensures stable and efficient network performance. These key parts combine to form Pharos Solutions. Let us first consider the CPE. Equipped with internal high-gain antennas, CPE series devices are compact, making deployment easy and flexible. The polarization graph depicts coverage and direction. Normally, a CPE antenna provides coverage for the 40 to 60 degree segment in which it is facing, creating a small wireless coverage area for point-to-multipoint connections. The base station, however, does not contain an internal antenna. This allows you to choose the most suitable external antenna depending on your specific demands. All TP-Link antennas are easy to install. We offer sector antennas for point-to-multipoint transmission, dish antennas for point-to-point links, and omnidirectional antennas for wide area coverage. The polarization graph indicate coverage and the degree of power aggregation. With the dish antenna, for example, the power is concentrated into a narrow directional stream for long-distance communication. The sector antenna has a wider coverage area but a shorter transmission distance. The omnidirectional antenna provides 360-degree coverage but has a limited range of approximately 1 kilometer. The current TP-Link CPE lineup includes our legacy outdoor access points, such as the 5210, 7210, and 7510, as well as our newly developed Pharos CPEs, the CPE 210, 220, 510, and 520. Each produces either a 2.4 GHz or a 5 GHz signal, and features the 802.11n standard with speeds of up to 300 megabits per second. Finally, we consider wireless base stations, such as the WBS 210 and the WBS 510, which have significantly higher gains than SOHO models. Outdoor antennas significantly enhance the signal strength and transmission range of base stations. In addition to professional hardware, TP-Link solutions also include powerful firmware. Our web-based interface features a wide variety of functions that are perfect for outdoor applications. These functions ensure better network performance, providing real-time throughput information and a spectrum analysis tool that helps you find the best channel. To make things even easier, our products do not require a reboot after configuration. Pharos Control, our free platform, is essentially a client-server-based network management system. It allows for the centralized management and maintenance of all Pharos devices in the network. You can use it to discover Pharos devices anywhere on the same server subnet and monitor the status of all connected devices. You can also use Pharos Control to update batches containing multiple devices simultaneously. The task scheduling function can execute device discovery, reboot, and firmware update tasks automatically. If one device ever fails to function properly, Pharos Control can detect the issue and notify the administrator via email. The MaxStream TDMA protocol is completely different from the 802.11 protocol. Problems may arise when using the 802.11 standard on a crowded network. The communication procedures used in 802.11 systems are roughly analogous to a crowded meeting. If two people were to raise their hands to speak at the same time, there would be a momentary delay while they decided which person would speak first. Then, once one person begins speaking, the second person would have to wait quietly until the first was finished. These procedures might work well enough with a limited number of participants, but the situation quickly becomes confusing if the group grows larger. In order to reduce the confusion and time that is wasted, someone is selected to direct the meeting and decide the order in which people get to speak and how much time each person will have to speak. The moderator, in our analogy, represents TDMA protocols, which help to preserve peak efficiency even as capacity is increased. The AP eliminates waiting time by prioritizing clients and distributing service in the best way possible. Now that we understand how the Pharos solution works, we can discuss how it can be used in specific scenarios to meet the unique demands of every user. Wireless internet service providers often use outdoor business Wi-Fi solutions to manage their networks. WISP solutions are cheaper and more flexible than wired solutions, and for this reason are very popular in the United States, Latin America, Southeast Asia, the Middle East, and Africa. One typical example involves a WISP that wants to provide internet access for a community with 40 households that is 50 kilometers away from the nearest ISP. After obtaining 100 megabit per second of bandwidth from the ISP, a long-distance wireless connection should be established to transmit data to and from the local community. Bandwidth will then have to be divided among the clients and delivered in an efficient way. First, we need to establish a 50-kilometer point-to-point wireless connection to transmit data between the base stations. Transmission over such a great distance requires a high-gain antenna, which concentrates signal power in one direction. We install a base station and dish antenna, which operate on either the 5 GHz or 2.4 GHz band, depending on the environment. The 5 GHz band is usually recommended as it offers more channels and is subject to less interference. To distribute access to subscribers, we use sector or omnidirectional antennas. Sector antennas feature a narrow coverage area that extends in one direction and transmits over distances of 1 to 5 kilometers. We then use a CPE to receive the signal from the base station and connect it to a SOHO router to provide internet access. We can choose the 2.4 GHz band or the 5 GHz band based on a variety of environmental factors. While the 5 GHz option is more popular and offers more channel options, its relatively higher cost may be a consideration. From this diagram, we can see the problems associated with the 802.11 standard. Total throughput declines dramatically as the number of clients increases. In contrast, MaxStream TDMA keeps throughput stable even as clients grow more numerous. With 25 clients on the network, the TDMA solution retains 90% of its maximum speed, while the 802.11 standard retains only 10%. As effective as TDMA is, it is only compatible with Pharos devices. It cannot directly support cell phones or laptops. Of course, having high capacity is not enough by itself. Test mode allows you to ensure optimal wireless performance and avoid interference on both the 2.4 GHz and 5 GHz bands. Test mode is listed alongside the various country codes and provides you with a wide range of transmission power and channel selection options. We have made it impossible to change the country code without agreeing to the terms of use. In addition to providing a reliable wireless network, our solution also includes powerful maintenance tools. Pharos Control is a centralized management platform that allows you to control all devices remotely. It consists of two parts, a server application and a client application, both of which run on PC. The server application should be installed on a device that is part of your local network, but the client application can be installed anywhere. We can use the client application to connect to the server and monitor or configure Pharos devices from anywhere. It should be noted that some functions, including port forwarding, must be activated to allow remote access to the server over the Internet. In summary, the Pharos solution for WISP includes base stations, antennas, and CPEs that create long-distance wide area coverage without the cost of a wired solution. The solution features TDMA technology to ensure excellent performance and test mode to boost network capacity and reduce wireless interference. Pharos control software makes it easy for a WISP to manage an entire network. While WISP makes up the majority of Pharos series customers, the solution can be applied in a number of different scenarios. Wireless surveillance has become a more popular application in recent years. To provide security and protection, cameras are deployed throughout a large area and are connected to the local wireless network. The structure of the system is similar to that used to create PTMP connections for WISPs, with CPEs connected to a central base station. A sector antenna and base station are an ideal combination for providing coverage within a 5-kilometer range. The Pharos solution, with MaxStream TDMA, provides improved QoS and low-latency data transmission for video and audio data. All Pharos CPEs have a secondary Ethernet port with PoE pass-through, which can provide power for an IP camera. A CPE, when combined with a camera, acts as a comprehensive unit that effectively serves the specified area. The Wi-Fi hotspot application may be the most familiar for everyday users. An outdoor CPE can act as an access point for all of your laptops and phones, spreading your internet connection throughout your entire property. In this scenario, however, where our phones and laptops are not compatible with MaxStream TDMA protocols, the CPE would function more or less as a SOHO standalone AP and would only be able to serve a limited number of clients. Finally, the transmission range of the terminal device, which rarely exceeds a few hundred meters, would limit the range of the CPE. We conclude that Pharos devices may be used as standalone APs that cover outdoor areas, but are not suitable for business Wi-Fi applications. For these situations, we would suggest our EAP Business Wi-Fi solution. Now that our introduction to the Pharos solution is complete, we can discuss two successful deployment cases from Peru and Indonesia. First, we consider the case of a wireless ISP in Peru that needed to provide point-to-multipoint coverage for an area with a 3.2-kilometer radius. The challenge arose from the fact that the area was already crowded with unregulated WISPs, resulting in severe wireless interference. Each CPE would provide 3 to 20 subscribers with 1 megabit per second bandwidth using switches. On the base station side, we used a WBS 510 equipped with a sector antenna. On the client side, we installed 11 CPE 510s, providing point-to-multipoint coverage from the base station to each client. The 11 CPEs share the 15 megabit per second bandwidth connection from the base station. All CPEs and base stations have been working well since February of 2015. Another successful case comes from Indonesia, where a wireless ISP wanted to offer a long-distance point-to-point backbone connection and point-to-multipoint coverage for its customers. The PTP connection included transmission between the base stations, which were 11 kilometers apart, and demanded bandwidth of 30 megabits per second. PTMP coverage between the client and the base station was approximately 1 kilometer, and one of the clients was a motel. All clients demanded bandwidth of 5 megabits per second. Implementation was made even more difficult due to the severe wireless interference on the 2.4 gigahertz channel. We used two WBS 510s, which were both equipped with dish antennas to build the backbone connection. In order to offer point-to-multipoint coverage, we used a WBS 210 with a sector antenna to transmit data from the base station to the 4 clients shown on the map. At each client terminal, we installed a CPE 210, which supports communications on the 2.4 gigahertz channel. As always, time has proven the excellent performance of TP-Link products, especially those used to create the backbone wireless connection. All CPEs and base stations have been working well since May of 2015. This concludes our business outdoor Wi-Fi training. If you have any questions, comments, or requests, feel free to let us know.